Mean of discrete frequency distributions. Welcome, everyone. Today, we are going to expand on what you already know about averages. Now, in our previous classes, you learned how to calculate the arithmetic mean of a simple set of data. You probably remember that process. You simply add up all the individual observations and then divide that total sum by the total number of observations you have. It's a straightforward method when you have a small, unique list of numbers. However, as we move into more complex topics, you'll notice that in many real-world scenarios, data isn't just a list of unique numbers. The same observation often repeats multiple times. For instance, if you were recording test scores for a whole school, you'd see the same score appearing over and over again. Instead of making a very long, tedious list by writing out the same value repeatedly, we use a more organized method called a discrete frequency distribution. In this format, we list each distinct value only once, and right next to it, we include its frequency, which is simply a count of how many times that specific value occurs. This will be the foundation for the formula we are about to derive in the next few slides. Understanding the concept. Now that we've established what a discrete frequency distribution is, let's think about why we use it. When you're looking at data presented this way, trying to find the mean by manually adding every single value one by one becomes incredibly tedious and time-consuming, especially with large datasets. To give you a practical example, imagine if the value 10 appears 50 times in your list. Instead of writing down 10, 50 times and adding them all up, it is much more efficient and faster to simply multiply 10 by 50. So if we have a set of observations, which we'll call x sub 1, x sub 2, all the way to x sub n, and each of these has a corresponding frequency, which we'll call f sub 1, f sub 2, up to f sub n, we can use a shortcut. The mean, which we represent as x bar, is calculated by taking the sum of the products of each observation and its frequency, and then dividing that entire sum by the total number of observations. This concept is what we will formalize into a mathematical formula in the next slide. The mathematical formula. If we look at the first line, the formula for the mean of a discrete frequency distribution is expressed as x bar equals the sum of f1 times x1 plus f2 times x2, and so on, all the way up to fn times xn, all divided by the sum of f1 plus f2. Up to fn it looks a bit long, doesn't it? To make this formula much more concise and easier to write, mathematicians use what we all call summation notation. You'll see this large Greek letter, sigma. We pronounce this as sigma, and it simply represents the sum of a series of terms. Using this notation, we can rewrite the entire formula much more elegantly as x bar equals the summation from I equals 1 to n of f, I times xi, all divided by the summation from I equals 1 to n of fi. Now don't let the symbols intimidate you. Let's break down exactly what each part of this notation represents so you can use it confidently. First, x bar represents the arithmetic mean that we are trying to find. Next, x sub I represents the ith observation, which is just a fancy way of saying the value we are looking at. Then, f sub I represents the frequency of that ith observation, or how many times that specific value occurs. The top part of our fraction, the summation of f, I times xi, is simply the sum of all the products we calculated by multiplying each value by its frequency. And finally, the denominator, the summation of fi, is the total number of observations in our entire dataset, which is the sum of all the frequencies. Now that we understand the logic behind why we multiply values by their frequencies, let's look at how we translate that logic into a formal mathematical formula. In the next slide, I will show you a clear, step-by-step process on how to apply this formula to a real problem. Step-by-step calculation process. Now that we have seen the mathematical formula and the sigma notation, you might be wondering how to actually apply this to a problem. Don't worry, it's quite straightforward if you follow a systematic approach. I've broken the process down into 5 manageable steps for you. First, you need to identify the variables. This simply means looking at your data table and clearly listing your observations, which we call x sub I, and their corresponding frequencies, which we call f sub I second, you will calculate the product. For every single observation in your list, you are going to multiply the value, x sub I, by its frequency, f sub this, to find a new value, which we denote as f sub I times x sub I third. Once you have all those individual products, you need to find the total sum of products. You will add all those results together to find the sum of f sub I times x sub I in our notation. This is represented by the sigma symbol followed by f sub I times x sub I fourth. You must find the total frequency. This is a very important step. You need to add all your frequencies together to find the sum of f sub I. This represents the total number of observations in your entire dataset. Finally, you simply apply the formula. Take that total sum of products we found in step 3 and divide it by the total frequency we found in step 4. This final calculation will give you your mean, which we represent as x bar. In the next few slides, we are going to walk through a real-world example involving football goals to see these 5 steps in action. First, you need to identify the variables. This simply means looking at your data table and clearly listing your observations, which we call x sub I, and their corresponding frequencies, which we call f sub I. Second, you will calculate the product. For every single observation in your list, you are going to multiply the value, x sub I, by its frequency, f sub this, to find a new value, which we denote as f sub I times x sub I. Third, once you have all those individual products, you need to find the total sum of products. You will add all those results together to find the sum of f sub I times x sub I in our notation. This is represented by the sigma symbol, followed by f sub I times x sub I. Fourth, you must find the total frequency. This is a very important step. You need to add all your frequencies together to find the sum of f sub I. This represents the total number of observations in your entire dataset. Finally, you simply apply the formula. Take that total sum of products we found in step 3 and divide it by the total frequency we found in step 4. This final calculation will give you your mean, which we represent as x bar. In the next few slides, we are going to walk through a real-world example involving football goals to see these 5 steps in action. Real-world example. Now that we have understood the formula and the theory behind it, let's put everything into practice with a real-world example. Imagine a scenario where a teacher is tracking the performance of a school football team. They have recorded the number of goals scored in 11 different matches. Instead of just giving us a long, messy list of numbers, the data is organized neatly into a frequency distribution table, just like the one you see here. In the first column, which we call x sub I, we have the number of goals scored. So, the team scored 0 goals, 1 goal, 2 goals, or 3 goals. The second column, which we call f sub I, represents the frequency, or the number of matches that resulted in that specific score. For instance, in 2 matches, they scored 0 goals, in 5 matches, they scored 1 goal, and so on. Our specific goal for this exercise is to apply the formula we just learned to calculate the mean number of goals scored per match. In the next few slides, we will walk through the calculation step by step, starting by creating a new column for our products. Step-by-step solution. Now that we have our data from the previous slide, let's move into the actual calculation. Step 1 is to create a new column in our table for the product of the frequency and the observation, which we denote as f sub I times x sub I. To do this, we go through our table row by row. First, for our first observation, where x sub 1 is 0 and the frequency f sub 1 is 2, we multiply 0 by 2, which gives us 0. Next, looking at our second row, where x sub 2 is 1 and the frequency f sub 2 is 5, 1 times 5 equals 5. Moving to the third row, where x sub 2 is 2 and the frequency f sub 3 is 3, we get 2 times 3, which is 6. Finally, for our last row, where x sub 4 is 3 and the frequency f sub 4 is 1, 3 times 1 gives us 3. Once we have these individual products, we'll be ready to sum them all up in the next step. Step-by-step solution, continued. Now that we have calculated all our individual products in the previous step, we move on to step 2. Here, we need to find the sum of all those products we just computed. In mathematical terms, we are looking for the sum of f sub I times x sub I. Looking at our results from the last slide, we simply add together 0, plus 5, plus 6, and plus 3, which gives us a total sum of 14. Next, let's move to step 3. We need to determine our denominator, which is the total frequency. This is the sum of all the frequencies, or the sum of f sub I. To find this, we add up all the number of matches from our original table, 2, plus 5, plus 3, and plus 1. This gives us a total frequency of 11. We will need both of these values, the 14 and the 11, for the final step in the next slide, where we apply the actual mean formula. Step-by-step solution, continued. Now that we have calculated our two essential sums from the previous slides, we move on to the final step of our calculation. Step 4 is where we apply the mean formula that we discussed earlier in the lesson. So the formula shows x bar equals the sum of f sub I times x sub I, all divided by the sum of f sub I. We take the sum of our products, which we found in the last slide to be 14, and divide it by the total frequency, which we calculated to be 11. Plugging in our specific values, we get x bar equals 14 divided by 11. When you perform that division, you get approximately 1.27. Therefore, our final answer is that the mean number of goals scored per match is approximately 1.27. As we move to the next slide, keep this calculation in mind, as I will highlight some common pitfalls students encounter when working with these types of formulas. Common mistakes to avoid. First, let's talk about confusing the x sub I and the f sub I. This is a very frequent mistake. Sometimes, students accidentally multiply the frequency by itself, or they accidentally use the frequency value where they should have used the actual observation. To avoid this, I want you to keep this simple rule in mind. X represents the value or the data point itself, while f represents how many times that specific value occurs. Always keep these two columns distinct in your mind. Next, watch out for using an incorrect denominator. This is a critical step. Some students mistakenly divide their sum by the number of distinct observations. For instance, in our football example, they might divide by 4 because there were 4 rows of data. However, as we saw in our calculation, you must divide by the total frequency, which was 11. Always remember, your denominator must be the sum of all frequencies, or the sum of f sub I. Finally, be careful with calculation errors during summation. It might seem simple, but it is easy to miss a row. Ensure that you have calculated the product of f sub I times x sub I for every single row in your table before you begin adding them all up to find your total sum. Taking your time with each individual multiplication will ensure your final summation is accurate. Now, before we wrap up our lesson, I want to pause and discuss some common pitfalls. Even if you understand the formula, it is very easy to make small errors that can lead to the wrong final answer. Key takeaways. First, it is important to remember that the mean of a discrete frequency distribution is essentially a weighted average. Unlike the simple mean we started with in slide 1, where every number carries equal importance, here, the frequencies act as weights. This means that values that appear more often have a larger impact on the final result. Second, we have the standard formula that we used to solve our football example. That is, x bar equals the sum of f sub I times x sub I, all divided by the sum of f sub I. This is your go-to method whenever you are dealing with data where values repeat, as it allows you to handle large datasets efficiently without having to list every single observation. Finally, always keep an eye on your denominator. The sum of all frequencies, which we write as the sum of f sub I, represents the total size of your dataset or the total number of observations. In our example, this was the 11 matches played. All right, we have reached the end of our lesson. Let's wrap everything up by reviewing the key takeaways from today's session. If you can master these 3 points, you'll be well prepared for more complex statistical problems. Great job today.